example 6, you're having a diagram with a circular disc, and the axis xy is given, velocity is given, radius of the disc is given, and okay, the cylinder row, surface conveyor belt moving. So you have two objects moving. One is the belt moving, one is the disc moving. Okay, so you need to determine at point A here, what is the velocity? It tell you what is the velocity. It do not ask you to find angular velocity. Okay, don't confuse between angular velocity and the velocity. Here it asks you to find velocity. So what I write on the whiteboard here is ask you about this V. So you need to find omega R always given. So you need to find what is the omega, what is the angular velocity. All right. So cylinder have a clockwise angular velocity. So cylinder, it tell you have omega 15 radian per second. Okay. So just a highlight here. On the rigid body, you start to use radian. Okay. So we have two solutions. The first one, you use vector analysis. And here, the example 6, it do not mention something, but when it comes to assessment, you always find there's no slipping happen. No slipping means there's no loss of energy, there's no loss of speed and so on. So point B on the cylinder has the same velocity as conveyor. So B will move as the conveyor. So B will have the same velocity as the conveyor. This is a cylindrical body, so you have your V tangent. You have your V tangent. So when you look at cylindrical body or circular motion, you only look at velocity at tangent and not velocity at normal. There's no velocity at normal because all the energy was in a tangent direction. However, you have acceleration in two directions. One is tangent, one is normal. So be careful on that. So here, B is given. Your VT is given here in the question. Okay. So when you transfer the question into free body diagram, so the question will not tell you which object to draw. So you need to be focused on the question itself. For example, this question, example 6, is asks you about point B. Point A. So point A on what object? So you just focus on that point. For example, A is on this. So when you draw free body diagram asked by the question, you need to pull the whole object, draw on your answer sheet there. So point B and point A, and then VB is the same direction as the conveyor. This is your VT or B. Okay. Then you need to find velocity at point A. So velocity of point A will be somewhere here, right? Will be somewhere here. All right. So, and this was rotating at this one. You're rotating in the circular motion or curvature motion. So at point A, you can draw tangent velocity here also. This is it just put like this one, but in your answer you can put like tangent direction like this way. Okay, then the angle. Okay. Okay. So velocity equation is VA plus VB equal to omega times R. Why this one? Because right hand rules, you always take omega times R. Okay. So how to derive this one? You refer to the previous slides, right? There's a derivation step there. Okay. So basically is what you draw a vector diagram and then you're completing this one. So you are actually looking at point A from B. Okay, point A from B. Okay, so you put in the value. You break A into I and J. This one you break into I and J. Okay. So there's a hint in the question. For example, X and Y. Okay. For example, X and Y. Okay. Then your VB is X direction. So 0.6I. All right. Plus omega. Omega is in the diagram. YK. Y negative K. Why? Why negative K and not positive K? Why? Why in this one, Y negative, not positive? Huh? What happened to O's? Because what? Use your right hand. Where's the omega? Direction. So Z is going in there. Okay. So here, our Z, we assume coming out from the screen. So negative is go in there. Huh? Then R stroke B is this one. So you break 0.5 I plus 0.5 J. This one. Okay. Okay. This diagram draw on the whiteboard explain why you convert this R into negative 0.5 J I plus 0.5 J. Okay. So this one is not told, but it's a hidden message from the diagram here. It's a round body. So this is your R A stroke B. Okay. And you break this one into here and here. Okay. All right. Oh, suddenly so quiet. Okay. So you do calculation. K cross J, you get negative, negative. Then K to I, you get positive. So you get J. K cross J, you get I. Okay. Here, you group I with I with I. Then you get what is your VA. You group J with J, then you get what is your VAY. So you have X and Y. You can do magnitude analysis. Square X, square Y, square root. You get the magnitude of VA. Okay. Right? You square this one, square root, you get this one. Then you get the direction. Get the direction. Same. Okay. So this one is positive 2.25. You get AY positive. Okay. Then you get the angle. Okay. So this one you already expert in the previous chapter. Second method is on the scalar analysis. So what you do is that you copy everything from your free body diagram. VA plus VB, VB given VA equal to omega R. Okay. Then you put in the angle you have. VA here in X and Y. So you have go up and go down, right? So you have VA and so on. Okay, then you do calculation. Okay, I will skip the mathematics steps. So at the end, you still get the same answer. Okay, so again, what is important, I did write on the whiteboard here. When you read question, rigid body always focus on 2 dot or 2 point. Always focus on the 2 point. Okay, so then we look at a new section which is called center of zero velocity, which is your location of IC, your center of gravity. So let's say you have a rigid body and you're comparing to a centroid IC here. So when you're looking at the position to a point A, right, and then there's a velocity here. So these particles was moving in this circular motion. So you know that VA is tangent, and then this body was rotating at this way. All right. So this one you read lah. This one you read. This is just tell you where is the center of centroid. So again, we are still using back the same equation. V equal to omega r. V equal to omega r. Don't confuse yourself with the diagram. Always concentrate on V equal to omega r. Where is the distance to get the velocity? So the rest you read. Just give you example. Okay. So all these are possible of instantaneous of center of zero velocity. Okay, all these you read. Meaning on the body, you have two points. 2 point, and then there's a center of center there. It's like your eyes and your mouth. Now you find a center point at your maybe your nose. Previous chapter, previous section, you look at your eyes and mouth. Now you add one more point, which is called IC point, which is your nose point. So now you're looking at your nose and your eyes, nose to your mouth, for example. Okay, the rest is still same. Okay. Now, example 7 is what link with your experiment, I think number 3, the link one, the L1, L2, L3, A1, A2, A3, the one that you turn 360 and then you measure the length. So, show how to determine the location of the instantaneous center of zero velocity for A, which is member of BC, and the link of CB, this one. So you have 2 cases there. So here, if you look at the first diagram, if you rotate point B, C will move in a translation, linear translation. Translation, you have 2. One is linear, one is like a wiper, with this circular translation. So this A to B is a circular translation, but BC, C here is a linear translation. So we look at first case. So point B, you know that it moves in a circular. So VB is perpendicular to AB. So when you draw a circular halfway here, so AB is always, B point always tangent towards the curve. Right? This one you know already. So what you do? When you look at chapter 5 question, you always extract the body of the interest point. For this one, you're interested in member BC. So BC you extract out. Then you draw the motion of one point, motion of another point. This one, motion circular. You put in B, label BC, and put in tangent velocity magnitude for B. Then there's an angle there. All right, there's an angle there. of your reference, horizontal reference, which is parallel to the C. The motion of point B causes piston to move forward. So velocity C move in this direction. You convert what you observe, and then the logical thinking of the movement, you convert into free body diagram. Or more correct way saying this is not a free body diagram, it's a kinematic diagram. It's because there's no force there. All right. But in the question that you see in test 2 and final exam, the question will ask you to draw free body diagram. So free body diagram mean in the question mean this one, means kinematic diagram. Right? So logic, right? Makes sense, right? Everything here. So you extract body from the question, focus on the point. Usually you have 2 points to focus on. Right? So for example, member BC, sure, you focus on B, focus on C, look at the motion, whether it's circular or linear. Okay. Then draw the velocity first. Then draw the velocity. Okay. Okay. Then you combine vector B and vector C together, you will get the location of 0 center. Okay, instantaneous center of 0 with IC. How you draw? This is tangent, right? Tangent 90 degree, you draw, it means you use your ruler. Your ruler have a sharp corner. So you just put your ruler here, you draw the line. Then you also take your ruler, you put on the C there. Then you draw a line. So your ruler is very important. If can, you bring the transparent one. Then it will help you to see where is your IC. Okay, then you mark the IC on your answer sheet. Okay, then you label. You start to put in the information. So if you stand at IC, you actually seeing this body swinging from left to right. If you're standing at IC, and if this B move, you're actually seeing this link swinging like this. So you have a angular velocity anti-clockwise direction. Yeah. So you pull the body, mark the 2 points, then look at the motion, draw the velocity. After draw velocity, use your ruler, predict where is the IC point. Then you stand at IC point, look back at the body. Then you imagine when in motion, how the motion works. Does it translate? Does it rotate? Translate, you have 2 motion. One is translation, one is linear, one is collinear, right? So in this case, you're seeing this body rotate angular motion, angular omega BC, anti-clockwise. Then there is a distance between IC to C, so you write RC/IC, means you stand here, you refer to C from IC. Okay, same with this one. Okay, you draw a vector. This one is B from IC. Okay, so this is how you determine without any calculation yet. This is on the free body diagram. Okay, so the next one, you look at this body, link C to B. So C to B, again, you look at CB, you extract CB out. Then you look at point C. Point C, when you rotate, circular. So circular, C must in the tangent direction. So velocity C will be pointing here. As this one rotate, C will be tangent go down. B also same. Circular, then go down. You extract 2 points, draw the velocity. Then next one, use your ruler. Put your ruler at the velocity here. Put a velocity here. Is there any intersection point? Yes or no? You understand what I mean? You have point here. You have point here. Okay. And you have BC. So you have V C, V B. Then what you do? You put your ruler, right, to find the IC point. You put the ruler like this, 90 degree. Then this is your IC point. You put your ruler here also. Is there any intersection point? No, the answer is no IC. Okay. So I did explain the step here. So R from the IC to C is infinity, or is in this way or in this way. So it's from somewhere very long way to the arrow also important. From the long way to the point, long way to the point. And you know the IC is somewhere here, but it's infinity. So when you stand here, you look at body CB, how the body CB rotate down. It's actually in the clockwise direction. Okay, it's like, although it's moving down. Okay, so R, you know that it's infinity, R infinity. So omega V equal to omega R, V equal to omega R, V equal to omega R. So you just pull the C there. You want to find what is your omega. It's 0. So there's no rotation by calculation. No angular motion, not rotation. So there's no by calculation. Although on observation, yes, you know that it's moving down, and it's rolling like this. It's not rotate like the previous one. So by calculation, in your free body diagram, you draw omega CV, and then you do calculation. Because infinite, you divide by infinity, you get 0. Infinity is a very big number, right? Same with another one, Same with this one. Okay. So yeah. Okay, so you continue with your understanding just now. Think very fast. Okay, example 8. You have learned how to draw the IC point, and then you look at example number 8. You have this is in the question. You'll see this is a link. We call it link or arm. So you have AB link and link B to D. All right, and as it move, so you know that this one pinned to the floor, and this one have a piston, like a block. So when you press something here, you press on B, this one will move in the translation, linear translation. So the angle was given 45, 45, 90. So actually you get a right angle, something like this, right? Get a right angle triangular. So dimension was given, velocity was given. Velocity was given. So block D move certain speed, determine angular velocity of link BD and AB, link AB at that instant show. Means that now you reverse back. Now this one, you move this block 3 meters per second. You observe how this one move. This one will move like this, right? Anti-clockwise. This one, clockwise. Make sense? Okay. Then this one is V. V equal to this one. Look at the whiteboard. You link V equal to omega R. You want to find the omega. Move the R to left-hand side. So you need to find the radius of this link. Link means from here to here. This is the radius R. So the rest you read. So D move to the right, cause AB rotate clockwise. So this one move, you rotate AB. Sorry, AB will move clockwise, move down about point A. So when you draw the motion equation, this is A, this is B. So this one move this way. So this is fixed. So when this one moves this way, it moves in a collinear motion. So collinear motion is in this way, but this point was linked to another body, right? Okay. So, and the angle was given 90 degrees. So coincident that the angle was given. If this angle was not given, means that if this one was given, B to C was maybe here to here, maybe 60 degree. But the velocity that you have, B will be 90 degree. So this example 8 is so coincident that the red arrow was 90 degree, same direction with the BD. But now you're looking at link AB. Yeah. So you draw to the body BD. You can pull AB another side and then BD another side. So I think this one is a bit fast. So I straight away I move to link BD. To just now I explained why VB is in along this one. So if BD was not 90 degree, I mean the BD body was not 90 degree, then this VB is coming from 90 degree. Means you need to extract this one to this body. This example is so coincident. The VB is along the BD body. Okay, so again, this is VB is a vector. Vector have magnitude and direction. Okay, so VB here, VD this direction because it's along this flat surface. So you VD here. So once you pick 2 points, then again use your ruler. You put your ruler here, you draw a line. You put your ruler here, draw a line. You combine the 2 lines, you get your IC point. Then you stand from IC, you look at that body. The body will swing like this way. So you draw R, B from IC. You draw a vector D from IC. Okay. Okay. So you are seeing this direction. Okay, you're doing this. You're seeing this body tilt like this. So tilt like this, you need to find what is the value of this one. Recall back what is velocity linked with angular motion. V equal to omega r. Then do the calculation, right? So you put in all the information there. You can calculate what is the r from the trigonometry. This is 90 degree. Okay, here is 90 degree. Because you use your ruler, use your ruler to point to the IC. So here is 90 degree. So you get a triangular. So the rest is just mathematics. You find how long is this one, how long is this one by trigonometry. Okay. Then you do calculation. V equal to omega r. So you just pull your r to another side. So you already find the RDC here. RDC, you know VD. Because here you don't know what is here. You don't know VB. So the question gives you this one. That's why you use this side. Okay, so you this side you do the calculation mathematics, you get the answer. Okay. You find the same. And why we can use this answer? These 2 points is like your eyes and mouth. They are at the same body. This velocity will be same as this velocity. Okay. So BD. Okay. So same, you can see the link from this D point, you find the omega BD, you take this omega BD to find back this one. You find this one first, then you find this one given, but you find what is this one, then you take this one divided by this one, you get this one. Then you reverse back. Okay. Okay, so the important part is how to link this point and this point by omega. Okay. Then the angle will be 45, go down from horizontal. Okay. Okay, then you go back, do the same for link AB. Link AB, you know the velocity of VB just now, B just now. So B is in a circular form, so it's tangent 90 degree. Right? So there's a 45 that you find just now. Right? Even though you draw a diagram with this one, you get 45. Okay, so same. Point A was no velocity because it was pinned to a fixed point. So don't suka go and add velocity. If it's pinned, then no velocity. Unless you see there's a roller here. There's a roller, and then there's a velocity. Okay. So same. You have the VB. You want to find this one. This one. Okay. So V equal to omega R. So you have the R. You have the VB. You're able to find omega AB. And the direction is anti-clockwise. Sorry, clockwise. So basically, we're recycling all the equation. It's only that the challenging part is the diagram. You look at one object, one rigid body, then move to another rigid body. Look at the motion, use your ruler, draw where is the IC, find the R from IC, then you link with omega. Okay. Okay, then this one I'll go very fast. This one is relative motion analysis for acceleration. So this one is the bin. So how this bin work? You start with the axis X and Y, and then there's a point A, point B, point C. So this one link, before it start, this one was at here, for example. So to move this dump at a certain degree, this piston will move up. When this move up, then there is a different velocity between A, C, and B, and so on. So still same. We still use back the vector equation. VB equal to VA plus V stroke A. You differentiate with time, you get acceleration. Right? So here, you also get back the acceleration. And again, acceleration, you have normal and tangent direction. Okay? Always break your acceleration vector into normal and tangent direction. Something like this, right? Something like this. So if you have a motion, like for example, this link, A move in the circular motion, and circular, you know that A, we don't know the direction, but we know that it's always have tangent and normal. Then you combine it with the square plus square root, you find the angle and the magnitude. Then here also same. Here also same. So it's pointing here. So and then the omega alpha is given. Right. So here is a translation plus rotation. This one I already explained in the previous slides already. Okay. It just tell you the steps the steps. Okay. So I will explain this vector later. This is a vector diagram. Okay, this one I think there's an appendix there. Yeah. Oh, okay. So this one you read, huh? You read. Again, we still use back the same equation. In a normal angular dimension, normal is omega squared r, like what I write on the whiteboard here. We're still repeating what I write on the whiteboard here. Okay, don't confuse by the diagram. Okay. So here, what you need to remember is you derive from VB equal to VA plus VB stroke A. Or if you forget, you just write, like for example, you forget A, B stroke A, what is that? Is A, B minus AB. Then you pull minus A to another side. Okay, this is how I memorize. I change the slash into negative. Okay, so then this that you see, VA will be 0 without slipping. So your kinematic diagram will be from gravitational center. Okay, now we'll start to look at center of gravity, G. The VG will be to this side, R will be from A to G, then the omega. This is how it changed from this diagram to this free body diagram. Okay. This is when without slipping, without slipping. Okay, the rest you already know. I just repeat. Okay. Okay, one more example 9, then we call it a day. Okay. Now, don't confuse by the diagram. You look at the diagram, it's still like a body, right? It still moves at a body. Both give you an angle, and there's a velocity given there. A move in the straight line actually. This is a flat surface, so straight line. So when this one A move down, you know that B will move up. But the velocity will be along this surface. So V is given, A is given. You know that A you can always break into normal and tangent direction. Okay, so rod AB confined to move along inclined plane. Point A has acceleration velocity given, both directed down the plane at the instant the rod is horizontal. Determine angular acceleration of the rod at that instant. Means it directed down the plane at the instant the rod is horizontal. So horizontal means here, right? So means you pull it is from somewhere up here, and then it become horizontal. There are two solutions. First, I use vector diagram, then I use scalar analysis. So both same marks in the exam. So first you draw kinematics diagram. You pull the diagram out, and then you only look at velocity and acceleration. Here, you mark the object AB, point A, point B. Then you mark RB to from A. Then rotation, you try to imagine how it rotate. How it rotate. Here, there is rotation from anti-clockwise. Omega also anti-clockwise. Here you don't know yet. You don't know yet. Later we need to find. Okay. So you should able to show that omega is 0.28 because you have velocity just now. You have velocity. you have 45 degree. And how you link velocity and omega, this one. V equal to omega r. Okay, you need to change this one. Velocity is at here. Okay. So the rest you read. You read. Your homework is to do this one, to come up with this one. How you convert from this diagram V2 meter per second into omega. Okay. Then you focus on this equation. Acceleration B will plus A equal to alpha. Why this? You have these two because you have A stroke B. This one AR to B, you have one acceleration magnitude there. You split into this one is your tangent. This one is your normal direction. So you break your AB, this one, into cos 45I and sin 45J, this one. Break into two x vector. Then same with this one. This one, move down because it's slide down. Right, slide down. So 3. So 3 cos 45I minus this one, minus because your y magnitude is pointing down. Okay. Then this one, alpha, your k is alpha, alpha this way. Okay, alpha, the right hand rules. Come out from the screen positive. Go in screen negative. Okay, alpha, so positive k times the 10. RB, this length is 10. I in x direction. Okay. Then omega, you need to find from the V. Then square RB is 10I. So here you have I and J. You group I together, you find what is the I magnitude. You group J together, you find what is J magnitude. So you can find answer. You can find what is your AB and then the alpha also. Yeah, this is simultaneous equation. You solve simultaneous, right? So if you forget how to do the cross product of IJ, go back to see the appendix. Right? So there's an angle, to always give the direction. So scalar, same equation, AB equal AB equal to AA plus this one, AB stroke A. Split AB stroke A into tangent normal direction. So AB, AB is go up along the slide, along the surface 45. This one, A was moved down 45. This one, A to B is alpha. Is rotate this way, right? Rotate this way. So alpha tangent, what is alpha tangent? Alpha R. Tangent direction, alpha R. So you take alpha R is 10. Okay, how to find normal? Omega square R. Okay, and this one, tangent is go up, go up. So normal go inside. Yeah. Okay. So here you have direction. You group in one direction, another one direction, you're able to find the missing parameter. Okay, you're solving. This one is split into x direction. This one is split into xy direction. You group x one direction, y direction. You will still get the same answer. Okay. Yeah. So rigid body, the one that I write on the whiteboard is important. Always split all this into the free body inside the free body diagram. Okay, we stop here. We stop here.